Welcome dear student. Today we will continue the last part of the chapter, that is chapter number 5 inside the atom. This is the last part, that is part 5 of this chapter. Let's begin with the session. So student, let's revise that what we have done in our previous session. Students, we have learned in our previous session about distribution of electron. Now what is the distribution of electron? So students, distribution of electron means electron according to the capacity of the shell, electrons are distributed in each shell like K, L, M, N. So in the K shell there are two number of electrons will be there. In L shell there are total number of 8 electrons. In M shell there are 16. In N shell there are 18 number of electron, and in the last shell, that is N shell, there are 32 number of electrons are there. So this is how electrons are distributed according to the capacity of the shell. So second was electronic configuration. Now students, what is the electronic configuration? The shell wise distribution of the electron in an atom of an element is called the electronic configuration of that particular element. Now what is the valency and electronic configuration? Students, valency of an element is related to how many electrons are present in that outermost shell. That means number of electrons present in the outermost shell of an atom. It is called as a valency of an atom. So let's start the chapter. Let's start the session. First we will learn about the relationship between valency and electronic configuration. The students, in your textbook one table is given to understand the relationship between valency and electronic configuration. So let's see the table. So in this table we have the symbol of elements, molecular formula of a compound. Molecular formula means how the element combine together to form a molecules. So this is a molecular formula. Valency of an element. Valency of an element, that means how many electrons are there in the last shell. So that will be the valency. Electronic configuration of the elements, number of valence electrons, that means how much electrons are present in the last shell of an atom. 8 minus x for x greater than 4. Okay, so this 8 minus x is only for that element in which the last shell contain more than 4 electrons. Okay, so let's start with the first element, that is hydrogen H. So the molecular formula of a compound is HCl, that is hydrogen chloride. So valency of the element is 1. Electronic configuration of the element is also 1, because in the last shell it is 1 electron, and number of valence electron will be 1 because hydrogen atomic number is 1. So 8 minus x is dash. Why? Because in the last shell of the hydrogen atom or in the first shell of the hydrogen atom there are only 1 number of electron. Okay, so 8 minus x only for them which contain more than 4 electron in their outermost shell. Now chlorine, molecular formula HCl. Valency of an element is 1 because the electronic configuration of the chlorine is 287. So number of valence electron will be 7. So students, here more than 4 electrons are present in the outermost shell. That's why 8 minus x will be 8 minus 7 is equals to 1. And x is nothing but a number of valence electron. Next is neon, no compound. Valency of the neon is 0. Why 0? Because if we see the electronic configuration of the neon, it is 288. So in the last shell 8 electrons are there. That means its electron octet is complete. Okay, so 8 minus 8 is 0. That's why valency of the element is 0. 4 is fluorine. So in fluorine, HF, hydrogen fluoride. So valency of an electron is, valency of the element is 1. See, electronic configuration 2, 7. Number of valence electron will be 7 students. Okay, so 8 minus x greater than 4. That's why 8 minus x, so it will be 8 minus 7 which is equals to 1. Okay, now students, here sodium NaEH, sodium hydride. So valency of an element it will be 1 because the electronic configuration is 281. So in the last shell 1 electron will be there and 8 minus x will be dash. Next is a Mg, that is magnesium. In the molecular formula of a compound MgCl2, that is magnesium dichloride, valency of the element will be 2. Why? Because the electronic configuration of this element is 2a2. In the last electron or the valence electron, in the last shell or the valence electron, there are 2 number of electrons. So 8 minus x will be again dash. Okay, so students, carbon and aluminium you have to do by your own. This is so simple, you can solve it by your own. That means just now we have seen that if more than 4 electron, then it will be 8 minus x, 8 minus number of valence electrons. So that will be the valency of that element. Now students, here one more table is given in your textbook. That is, write down the number of electrons present in the outermost shell. Let's see the table. Here elements are given and Z is given. Student, what is Z? The number of protons in the element. Okay, let's see. So in the hydrogen, number of proton are 1 is 1, carbon 6, sodium 11, chlorine 17, nitrogen 7. So for hydrogen, number of proton is 1 and number of electron in the outermost shell will be obviously 1. Okay, and in carbon, the number of Z or number of proton is 6 and the number of electron in the outermost shell is 4. Why 4? Because if we see the electronic configuration of the carbon, it will 2, 4. That's why valence electron will be 4. Sodium 11. So number of electrons in the outermost shell will be 1 because the electronic configuration of the sodium is 2a, 8, 1. For chlorine it is 7. Number of proton will be 17 and number of electrons in the outermost shell are 7. And the electronic configuration of chlorine is 2, 8, 7. For nitrogen, number of proton are 7 and number of electrons in the outermost shell or the valence electron are 5. Student, another table is given in your textbooks. Let's see. So the number of electrons of some elements are given here. Okay, so by using it, right, we have to write the electronic configuration, number of valence electron and valency of the respective element. Let's learn the table. So elements given are lithium, carbon, magnesium and oxygen. So number of electrons are given. That is, for lithium it is 3. So let's see the electronic configuration of lithium. It will be 2, 1. Number of valence electron will be 1. Students, valency same as that of valence electron 1. That is, if the number of valence electron will be less than 4, the valency will be same as that of valence electron. Remember this thing in your mind. For carbon, the number of electrons are 6. So electronic configuration will be 2, 4. Valence electron will be 4 and valency also will be 4. For magnesium, number of electrons 12. So what will be the electronic configuration? It will be 2, 8, 2 and number of valence electron will be 2. So valency will also be a 2. For oxygen, the number of electrons are 8. So electronic configuration, in the first shell 2 electron, in the second shell 6 electron will be there. Okay, so number of valence electron are 6. So what will be the valency of oxygen? It will be 2. How to? Because see, in the oxygen atom, the number of electrons are more than or greater than 4. So it will be 8 minus x. That means 8 minus 6. So 8 minus 6 will be 2. So this is how the valency of oxygen will be 2. Now let's see the isotopes. What are the isotopes? Students, isotopes can be defined as atom of the same elements. Listen carefully. Atom of the same elements that possess the same number of protons and electrons, okay, but a different number of neutrons. So students, what are the isotopes? The atom of a same elements. Okay, that means if it is chlorine, then the chlorine again it will be a chlorine. Okay, atom of the same elements, but In one chlorine there is a number of protons and electron will be same, but in another element, in another atom, it will be a different number of neutrons. Let's see an example. For example, see here a diagram to show the isotopes of carbon. So students, for carbon there are 3 isotopes. So you can see in the first isotope of a carbon, that is 6C12. So in 6C12 there are 6 protons and 6 electrons, and 6 protons, 6 electrons and 6 neutrons. Okay student, now student, on the C, in the upper part, 12, what is a 12? It is a mass number. Now what is mass number? It is number of protons plus electrons, so it will be 12. And neutrons, 6 is the atomic number, that is Z. Okay, only the number of neutrons, sorry, number of protons. For second isotope of a carbon, it is 6C13. For that same number of protons, that is 6 plus 6, it will be, 6 number of protons and 7 number of neutrons, 6 electrons. So it will be total 6 plus 7, 13. And for the next carbon isotope, it will be 6C14. Students, here you can see 6 number of proton and 6 number of electron, but the number of neutrons are increases by 2. So the Z, that is atomic number, sorry, the mass number will be 14, and the proton number, that is Z, will be same. Yes, Z will be same, and mass number A will be different, that is 14. See, so mass number is different. See, 12, 13 and 14. This is the difference in their mass number, but you can see the proton number are same, that is 6 in all the 3 isotopes of carbons. Now students, another table is given here in your textbook. So by this table, see, the isotopes have same proton but different neutron number. Let's see the table. Here isotopes of carbon is given. We have seen in our previous slide. So isotope 12 carbon, carbon 12, carbon 13 and carbon 14. So mass number A, that is, it will be for C12, it will be 12, 13 and 14. Okay, and proton number, what is proton number? That means only Z, only proton number. Okay, but mass number, it is the addition of proton number plus neutron, number of proton plus neutron. Okay, so proton number will be same, that is 6, and neutron number will be different, that is N is equals to A minus Z, that is 6, 7, 8. Now let's see the isotopes of hydrogen. Now students, there are 3 isotopes of hydrogens are there, it is protium, deuterium and tritium. For protium, the protium, the mass number, okay, for mass number will be 1. That means mass number means number of proton plus neutron, so it will be 1, and number of proton will be 1. Okay, and for deuterium, you can see for deuterium mass number is 2. Okay, mass number is 2, but the number of proton in deuterium will be same as that of protium. Now tritium, for tritium you can see the mass number is 3 and number of proton is same. So you can see in all the 3 isotopes of hydrogen, number of proton is same and mass number is different, that is 1, 2, 3. So these are the 3 isotopes of hydrogen. Now let's see the isotopes of chlorine. Students, for chlorine there are 2 types of isotopes. First is 17 chlorine 35, and next is 17 Cl37. For the first, it is said that chlorine 35. Okay, so for the chlorine or Cl35, the proton numbers are 17, neutrons number are 18, and electrons will be also 17. Okay, so this in first isotopes of chlorine, protons and electron will be same, and in the chlorine 37, protons and electrons are same, but only the neutrons number will be increases by 2. That is in first it is 18, and in second isotope, that is 37 Cl, it is 20 neutrons. Now students, let's see some uses of the isotope. First is uranium 235 is used for nuclear fission and production of electricity. This is a nuclear fission reaction, of uranium-35, and it is a production of electricity by using uranium-235. You can see a setup of a nuclear reactor by which electricity can be produced. Second is some radioactive isotopes like cobalt-60 are used in medical treatment of fatal diseases like cancer. Iodine-131 is used in the treatment of goiter disease of thyroid gland. Uses of isotopes. The radioactive isotopes are used for detection of cracks, that is leakage, in the underground pipes. Example, sodium-24. So by using sodium-24 isotope, we can use this isotope to detect the cracks in the underground pipes. Radioactive isotopes are used for food preservation from microbes for longer duration. The radioactive isotope C12, that C14, that is carbon-14, is used for determining the age of archaeological objects. Our next and last topic is the nuclear reactor. Students, first nuclear reactor is the Bhabha Atomic Research Center in Mumbai, that is in shortly it is known as BARC. Let's see the BARC, nuclear reactor. So student, first of all, nuclear reactor is a machine that generates electricity on a large scale by using atomic energy. You can see this picture of BARC in this slide. In a nuclear reactor, the nuclear energy in atom is released by bringing about nuclear reaction on the nuclear fuel. Let us understand a nuclear reaction with example of nuclear fuel, namely uranium-235. Students, on bombardment with slow speed of neutron, you can see when a neutron is bombarded on a uranium-235, it undergoes nuclear fission. Fission means splitting up the uranium-235 molecule. Okay, so nuclear fission to form nuclei of two different elements, that is krypton-92 and barium-141, and 2 to 3 neutrons are released during the nuclear fission reaction. On decreasing the speed, these neutrons bring about fission of more uranium-235 nuclei. In this way, a chain reaction of nuclear fission takes place. A large amount of nuclear energy is released during a chain reaction of fission. The chain reaction is kept under control to prevent the probable explosion. And to control the chain reaction, that is to control the nuclear fission reaction of uranium-235 in the nuclear reactor, it is necessary to decrease the speed and number of neutrons. So students, this is a very important step which is taken in nuclear reactor to control the nuclear fission reaction of uranium-235. For this purpose, of following provision is made in a nuclear reactor. First is a moderator. So graphite or heavy water is used as moderator for reducing the speed of neutrons. Second is a controller. To reduce the number of neutrons by absorbing them, rods of boron, cadmium, beryllium, etc. are used as controller. The heat produced in the fission process is taken out by using water as a coolant, and water is transformed into steam. By means of this, heat turbines are driven and electricity is generated. In India, total 22 nuclear reactors in 8 places are functioning. Apsara at Bhabha Atomic Research Center in Mumbai is the first nuclear reactor in India which went critical on 4th August 1956. India has large reserves of the element thorium-232. Therefore, Indian scientists have developed a future plan for nuclear reactor based on production of the isotope uranium-233 from thorium-232. With this, we end this chapter, that is inside the atom. Thank you, students.